So this is the OSF production readiness for the Intel Xeon Scalable Processor Servers. Most of the content has been reinforced in the Hancock's as well as Johnny's presentation, plus Chris also talked about it, and then by Dan's team. So this essentially kind of summarizes all these things together. So we'll start off with, I'm co-presenting this with Jonathan, and we kicked off this in the morning. So I will cover the, the process side of how exactly are we enabling open system firmware on the Xeon platforms. I'll show the history of what has been done so far, and an element of process around how do we enable this before the platform launch and after the platform launch. And then Jonathan is going to cover most of the SapphireRapids OSF status update, what is a value prop from CSP's perspective, and what are the key use cases that they felt that are extremely useful from OSF value prop perspective. On the Xeon platforms, as you already heard about, Intel firmware support package basically lays the foundation work to integrate with wide variety of the bootloader, code. This includes both Tiano core based as well as the core boot and slim bootloader, anything emerging. But the focus is to essentially have Intel firmware support package that does the core initialization. All the platform code happens via the the bootloader code, and we are agnostic to any specific bootloader. So you can enable pretty much any bootloader. And then, of course, there is a payload, which is Linux boot and UEFI-based payload, and then before you boot the operating system, right? So our goal is to essentially collaborate with the ecosystem to enable the OSF-based solutions. And then the intent is really to make sure that these are production ready. This is no longer a POC specific focus, but the goal is to make sure that when we collaborate with the ecosystem, including hyperscalers like Meta, ODMs, OEMs, IBVs, the goal is to essentially have a collaborative work to enable this, and then ensure that the firmware is ready on Intel platforms when the platforms actually get launched. That's really the core theme behind it. So if you look at the journey of OSF support on the platforms, I think it started off with me and Jonathan back in 2019 saying that let's figure out a best way to take core boot and try this on the OCP platform, which happened to be a Tioga Pass platform, 2-socket platform with the Skylake scalable processor, the configuration. We spent a lot of time to actually figure out what is the best way to enable that. That was really a POC. And then, fast forward, last year, we essentially said, let's go figure out a best way to enable this on a production grade platform, which is Cooper Lake, OCP Delta Lake, single socket with a Cooper Lake processor on it. We expanded the collaboration with not just Intel and Meta, but we added ODMs, so Vivian and Quanta in this case. So we essentially had a collaborative work. Now, notice that, there is not a whole lot of IBV engagement in, back then. And then, fast forward on the 4th generation, the Xeon platform, which is called SapphireRapids, you can see there is a vibrant ecosystem. This essentially includes significant number of ODMs. You heard a talk about Supermicro and Vivian on the SapphireRapids, and then we had, ByteDance talking about enabling, as well as Meta talking about that. So we have a significant number of OEMs as well, like Lenovo and others. And then we have AMI, 9 Elements, and CISPRO, all these IBVs actually coming together to enable this. So it's a fairly vibrant ecosystem, and the goal is to make sure that we essentially have a mainstream open system firmware ready solutions when Xeon platform actually gets launched. That's really the core theme behind it. This includes single socket and dual socket servers. Now, the process of enabling for the platforms that haven't been launched, it's a 2-step process. So before the platform launch, we essentially have a very collaborative, the ecosystem working together to address the common problem. So there is a silicon core that we need to go develop on top of the existing core boot foundation layer. for a given platform, and there is also a platform code for a given platform. So this includes Supermicro, Vivint, Quanta, Mytek, and you name it, right? Lenovo. All these platforms have a different, some element of platform customization that has to be developed as well. So the goal is to make sure that we collaborate with CSPs, OEMs, and ODM ecosystem and IBVs together to be able to actually do this before the platform launch. And this typically happens using a private GitHub repo. You have to have an NDA with Intel, primarily because there is a lot of pre-launch, the IP that we really want to be able to, share, but it needs to be an NDA under the umbrella of MP-NDA, process around it. The interaction with Intel, of course, we are also developing the firmware, and there is also core boot development happening in parallel. So there is a very tight collaboration with Intel and the rest of the, the developer community to be able to do this in a lockstep mode before the platform launch. So you find an issue, you log an issue, we fix it, and we may find an issue in the core boot code. So we have to actually look at these two things going in parallel at the same clip from a development, pace perspective. Slack channel, email are the ones that we use, sync meetings, periodic sync meetings, and so on. After the platform launch, things are, obviously whatever we work on needs to be upstreamed. There is an element of platform code, silicon code that gets upstreamed. Intel firmware support package binaries get released as well with some collateral around it. So that is also available for broad market consumption. And then obviously if there are issues with Intel, if there are bugs or issues or some support things on the firmware support package, you have to go through the Intel standard support process. If it is something related to core boot, there are a wide variety of options. One is you can use the core boot mailing list as a way to get the support. It could be self-support, or it could be through IBV ecosystem, right? So that's kind of where things fall under. So before platform, after platform launch, we want to be able to do this collectively with the ecosystem to really enable the production-grade open system firmware for Xeon platforms. With that, let me hand over the next part of the discussion to Jonathan. So he's going to cover the actual mechanics of how we ended up enabling, what are the features we did. Go ahead, Jonathan.
Thank you, Reddy. So on the left-hand side, we can see that with this OSF stack from FSP to core boot to Linux boot, all the different layers, they have different purpose. Like the FSP is the silicon initialization package code, and is a bread and butter of Intel. So Intel provide great support for it, and they own it. And then on the core boot side, it has all the platform initializations, and it has a lot of the firmware core features inside there. On the Linux boot side, it has all the device drivers, like file system drivers, network drivers, and bootloaders. So the Linux boot is a single binary, can work for all the platforms. It has nothing to do with the platform, right? Because Linux runs on all machines. Now, core boot is the same code base for all different servers, but you build it differently. You through the kconfig, right? So that needs customization for each platform. And then underneath it is the SoC support that comes from the silicon vendor. So before Intel launches their processor, right? Of course, we cannot upstream the code related to SoC, but we would upstream all the common code changes. So we are in the process of doing that. We have hundreds of pages. We already upstream like 50 of them. We have another like 50 to 60 in the fly. To enable the industry, we will also have a how-to guide. So given all the access you have, right, upstream code and the Intel binaries that's publicly available, how you will be able to support your server, customize your server in weeks, right? So we are in the process of doing that. You can see that Supermicro is a good example that they did everything by themselves. In several weeks, they get everything running, and they are happy to contribute back, and they are helping to write in part of the how-to guide. We will have OSF blocks that in the last 2 years, we had blocks on Tioga Pass, we had blocks on Delta Lake, and then we will have a block next year on SapphireRapids-based OCP server. Intel will help to provide the FSP collaterals, like FSP binaries, ME ignition binaries, microcode binaries, provide that to the Intel to enable the industry. Next page. So we heard Biden's talking about hyperscaler value proposition. We heard win-win super macro given ODM, OEM value proposition. We heard from 9 Elements about IBV value proposition, right? So from us, from the metal side, right? So so those are the values we see. One is that we untap the Linux talent. So we have limited experience for UEFI, but we have tons and tons of expertise on Linux, right? So like I'm part of the core kernel OS container team, basically, right? So Coreboot has a Linux kernel style in terms of design philosophy, community process, coding standard. And Coreboot with one code base supports multiple generation, multiple data, multiple vendor SOCs. From the security and ownership side, Coreboot gives us full control of however we want to customize it. Like Chris talked about CBNT support. We were able to get it into a couple of months. And last but not least, as we said, it's not just Meta, right? It's tens of companies. It's a dozen of companies working together. So we all together, we lift the boat, right? 70% of the firmware features are the same between Facebook and Google and the Badlands. We face same problems. We may have our unique problems, but the unique problem, we can take it out and ask for design feedback, right? So, so with this, and also the Linux drivers, so the device drivers, we only need to write it once. For example, CXL driver. We don't need to write a UEFI CXL driver. We just use the Linux kernel CX driver, right? That has good qualities. That would focus the whole community's effort into one driver and make it super, super solid. We can go to the next page. Another benefit we see is it really accelerates the new technology time to production. So let's take CXL as an example. CXL as a brand new solution, technology, right? Everything is new, from spec, right, to hardware, to software. Everything is new. Everything is in development, right? It's like a chaos. So if you don't carefully manage it, it would become a chaos. But in our case, right, you can see that on the we are the center of the spec definition. We design our own hardware, right? We work closely with device vendors, except of the ASIC, right? We own everything else, and also we work closely with Intel. So Sapphire is supposed CXL 1.1, and then on the software side, we have full control. We write our own infra tools. We control. We have great expertise in kernel OS, and we write our own OpenBMC. We interact with the device vendors for the device firmware through the CXL spec interface. So that's all we're controlled. Now, the last piece is host firmware, right? So with OSF, we have full control of the firmware as well. That really enabled us to unblock our CXL program execution. So that made a huge evidence that makes it really clear to everybody that the value added by the OSF. Another page. So this is an example of how OSF helps the new server engineering process, right? During the new server engineering process, when an issue happens, the issue could be in hardware design, hardware stability, or silicon problem, or software problem, other software problem, not necessarily host firmware, right? How to debug all of those things. So our experience is that OSF really give us the ability and a fast turnaround to solve those, to debug and solve those problems. Sometimes when we report an issue to Intel overnight, we get an answer and we get it fixed. And we also use OSF as a method to find out the optimal power and performance and get the stability and the boot time and say, hey, this is what firmware should be able to achieve, right? So then we can get as a reference that that's something we would demand our traditional firmware to also reach. And going forward, we actually will use OSF as the one to do pre-silicon and bring up effort, because we firmly believe that would make a huge difference and accelerate our time to production together with our silicon vendors. Next page. So as summary, the fundamental cornerstone of OSF is the silicon initialization package. So the FSP enables that. We appreciate that Intel starting with SapphireRapids, making it a product, and we have no worry that it will be product supported. There is very, very close collaboration with the OCP ecosystem, thanks for the Intel's permission letter that allows us to discuss all the technical details, help each other. With that collaboration, we are on track to deliver the OSF solution on Intel SapphireRapids process. Right? We are on track to reach production ready from our side, while Balance is moving into production in the next months. Core boot and Linux boot are key enablers for the OSF. It untaps the Linux talent, and it reduces the time to production through accelerating the debugging and the issue resolution. So this is call to action. We really want to work with the community, right? Because as we can see, 70% of the problems we face, we believe the industry also face. So we want to help each other. We don't want to spend too much resources on host firmware from Meta. We hope you can experience the OCP OSF ready solutions, and you can take advantage of it and then contribute back. How do you join the community? Join the OCP OSF call. There's one call for North America, another call for Asia Pacific. You can go to the OCP OSF wiki page to see the schedules. You can contact us at any time. You can also join the core boot and Linux boot communities. I think that's the last page.
Yeah.
So how many minutes do we have?
So we have 2 minutes if there are questions.
I have a big question. I think you are really doing the open source very well, but in open source, usually they are enable individual contribution, right? What I see is now, unless you are working for a big corporation, you have to access a huge server machine. You are not able to develop anything on OSF. So is there a plan to enable individual contribution?
Right.
Excellent question. Yeah, community level.
Yeah, great question. So if we look at the OCP history, OCP started with open hardware, right? So Facebook, not Meta, contributes to our server design spec. ODMs contributes to the server spec, right? So the next step is OSF became a OCP first top-level project. That means people buy a hardware, and then they can get OSF on, get OpenBMC on. You pretty much can run, right? Can run. And what's the third step? The third step is, so through the second step, you basically enable the smaller CSPs or smaller company, but still you need a mid-sized company. Like Kankan just asked about enable individual engineers or even smaller companies, how you do that, and academics, how you do that. So I'm very glad to see that in the past several days, I have a lot of talk with the OCP new foundation, new team, new leadership team, they are very supportive of the experience center concept. And we actually have the hardware arrived at the data center already. So we just wait for OCP to do some announcements, to give some reliability release, and then we'll start to power on. And at that time, just email us, right? We will give you the access to Delta Lake, maybe later on to SapphireRapids based server. You can experience whatever you like. Hope that
Great
answers
question.
your question.
Yeah. Any other questions? 1 minute.
Just one more question. Have you considered making a QEMU platform? So I can develop everything on my.
Yeah, that's an excellent idea. Ourselves, we don't have the desire. Ourselves do not have to have it because we have hardware, and we can even use, they say, Intel CMIX, right? But QEMU is an excellent idea, which is something we want to get some support from the community, right? Say, hey, let's say, oh, QEMU is important. Let's work on it together. I'm sure there are others as well.
Yeah, yeah, it's an excellent idea. I think we just need somebody to take the leadership on that one and start the work. But it's an excellent option too.
Yeah.
All right, thank you. So let's get on to the next topic.
Thanks.